Okay, so hello. Today I'd like to talk about audio framework.
There is a background noise on your background. Background noise.
Yeah.
And seem like it is generate some feedback and increasing over the time.
Okay. So yep. So yeah, I know I'm writing this as a best practice, and I hope that we can have a discussion here for expanding the functionality of audio. And before that, let me introduce myself. I'm working for Sony as a digital engineer, the digital ASIC designer, and embedded software engineer. And production involved is some LSIs and PlayStation 2 and 3, and digital camera like a Sony Alpha 7 and Sony TV, Bravia. And now I'm working for Expressions. And Expressions provides SDK and uses NuttX as its operating system. We also use not only the kernel side, but also the app side too. And what we already contributed on the Expressions work, we ported the NuttX on the Expressions several years ago, and fixing some bugs entering the current NuttX. And audio driver before to interface like and example code. And on personal work, from this year, I could do this, and I contributed the 3 functions like music micro language parser and frequency modulate synthesizer and simple audio utility library. And next contribution we are planning is about audio framework. The Expressions has an audio capability. The Expressions SDK already included an audio implementation to take advantage of Expressions audio, but the current Expressions audio framework is specific to Expressions, of course, and it's very complex and heavy because we have been used code from the past production and modifying and patching implementation. So we are now considering re-architecting about audio. So since we are re-architecting, we would like to define general purpose audio functions on NuttX and be able to take advantage of the specific functions within the defined interface. So in today's presentation, I'd like to introduce the audio framework basic structure that we are currently considering. And I hope to share our idea and discuss with community members. So, and basically, there are 2 major functions are expected to be performed as audio. One will be the playback function, and the other is the recording capturing function. The both playback and recording will be read from or save to the specific file format, like WAV or MP3 or etc. And however, a number of parameters must be set to take advantage of these functions, like channel number, bit width, bit rate, compression. This is needed for compression format, and sampling rate, input-output devices choosing. And of course, these parameters will already be configurable in NuttX audio driver. But there are not only features required by audio. These are cases where you may want to use the audio signal processing, or more recently, the recognition is very famous. So the example of the signal processing is like equalizer, or gain control, or dynamic range control, mixer, filter, etc. And audio recognition, very famous function is voice activity detection. And recently, voice recognition can be done in the microcontroller board by using the TensorFlow, like micro, as you know. And music purification, for example. Yeah, this kind of the feature is, I think, required on the audio functionality. Of course, it depends on the application, but so to achieve some how to say these how to use this functionality, that this is just a kind of the example of the signal flow. So the playing the music, playback music, so or music data from the storage and decoder to decode to make the LPCM, and equalizer, for example, and some operating tone is mixing, and gain control and output. And audio input case is input the audio and filtering and encode to the kind of the compressed format, and file access to save the storage. And in parallel, for example, voice recognizer is here, and the application do some action depending on the recognizing. So the question is how to implement these functions, and how to unify them as a NuttX platform, as the hardware has different functions depending on the device. Now there are three major implementation methods, we think. And one is all, or implement all on the audio driver. So this advantage of this method is that only one file descriptor is needed, but it tends to complicate the application audio driver, and signal flow cannot be freely configured. Of course, it's possible, but to make it, it's very complex. And if we take this way, the number of I/O control is explosive. So I think this is not a good idea. So the second way is to create each function block independently and implement it in application layer. So this method allows free configuration of signal flow. Also, by using loadable application can be built with minimum amount of memory required for each use cases. In addition, the one file descriptor is consumed only. However, in this case, if the hardware has the specific functions, how to generalize it is more difficult, because this one is block size implemented directly, so there is no hardware things here, because it's a software implementation only based on, basically. So the third method is to define device interfaces for each function block, and then this method allows free configuration of signal flow, optimal memory usage by module loading. Int mode we can use on NuttX already. And simplicity of each function, of course, but also allows the driver to be configured as a lower upper structure to absorb differences between the platform. The weakness of this method is it consumes a lot of file descriptors resources. However, some functions such as recently method merged FM synthesizer do not require a driver, so the best solution is hybrid use of the second and the third. This one and the second last one. Yeah, and it's as a side note that when configuring the signal flow in parallel, the life cycle of the memory used may be different for each block. So memory release management with reference counter is necessary. And the NuttX audio data structure already defined the reference counter and the semaphore for exclusion, but not used right now. So for achieving this kind of the structure, this kind of the signal flow, they will be actively be used in such cases, and it will be useful to have some kind of the utility library for this use. I'm planning to include some useful functionality in audio util libraries. Yeah, the conclusion to make the signal flow configurable or separate each functions in each drivers in the application or the library hybrid method 2 and 3. And it is also useful to add the functions for it to the audio utility library. Yeah, that's all. Thank you for your attention.
Thank you, Koizumi-san, for your presentation. And what do you think, since you are the one that designed the initial audio support? Can you share some thoughts?
Oh, sorry. Actually, right now, from this year, I lost my hearing, and I got surgery implant devices on my head right now that to recover the hearing, but not how to say good hearing yet. So please more louder and slowly, please.
Ken, you are muted.
Sorry.
Ken, you are muted.
Okay. Yeah, I actually had earphones on, so I can really hear the volume. Is this better?
Yes, it is better.
Okay.
Thank you.
So I switched to just my normal speakers. I actually did the audio system, 9 years ago? I think I was looking, it was 2013. It's been a while since I've looked at it. And I definitely see the concern where you've got a lot of stuff going on down in the driver level, and trying to configure the chain of events, right? You want to be able to have different modules. One, like the equalizer. If you go back to your slide where you're chaining those together, right? Where you've got an equalizer and a mixer and a gain control, etc. I can see where if you have a single audio driver, you're right. That means that there's a lot of I/O controls with a lot of setup for just a single driver. I like your idea of having a driver from one where you have the ability to change.
No, just put it up there because it'll get falling off the end of the bed.
Yeah,
you can go back.
Please mute yourself. Let me see if I can.
Yeah, if we can go back to that one.
Let me help.
Yes.
Okay.
I mean, this. Yeah, I see the idea where it's using a number of file descriptors. Which is 1, 2, 3, 4, 5, 6 in this case, which is not extravagant. But I can see where if you have, as your audio gets more complex, that starts to grow more and more. I don't necessarily see an issue with having this number of devices, but I believe you would want a way when you're chaining these together at the driver level. If each of these are a driver, where you would want to have to go through the user mode back into the top and back into the application and send actual audio data through that chain. Seems like what we'd want to do, or what we want to do, is we have a way in each of the drivers to be able to have the kernel set up an audio chain, right, where you do have a driver and we have some standard interface for data coming into the module and then its output. So those could be chained together at the kernel level, but directed, have that chain set up by the application. So let's let each one of the drivers of the application tell the driver, your input needs to come from this other kernel node driver. Right? That way, the application is configuring each of those, but the actual flow for audio data doesn't have to make jumps to and from your application. I don't know if that's what you had in mind when you were doing this diagram.
Couldn't catch it.
Did I speak too fast?
Koizumi-san,
Yes.
did you?
So I guess the question is, with your idea for this diagram, when you have these multiple drivers, were you thinking to have the actual audio stream, flow through that driver interface, that file descriptor, and have the actual audio flow through the application? Or was the idea that you could set up a flow between the kernel drivers where they can send data directly to each other? Otherwise, you're going to start getting a lot of added latency and a lot of added delay. What was kind of your thought there?
Oh, so you mean that, for example, the hardware supporting how to say the equalizer already inside of the device. So such things. What your question is the path through via the application is not good. You mean?
Oh, okay. So you're saying that the hardware already has the connections to be able to send the equalizer to the mixer to the gain control, and you're thinking just have a different driver for each function within the hardware. Is that my understanding correct?
Sorry. I
okay.
expected you close caption on the YouTube, but now this channel doesn't.
Oh, so
yeah.
I'll say it slow. So you're saying the hardware already has an equalizer and a mixer that gain control, and the hardware automatically takes the data from the equalizer into the mixer and into the gain. In other words, that those aren't individual blocks. You have to somehow pass data from one to the other. The hardware already passes that data. Is that correct?
Guys, just let me interrupt you a little bit. I think, Koizumi, your background noise is not helping Ken to ask. I suggest we turn off your microphone while Ken do the question. Then you will understand it better, and then you reply. I think now it will be better, correct? Ali, the sound now is clear, correct?
Yes, the sound is clear.
Yes, I think that's the point. The noise is not helping. So
mixer, the gain control, etc. And you're showing, connections through the application. And so my question is, the hardware that you're looking at, or does the hardware automatically pass the actual audio data from one block to the next? Or is that something that the application has to direct that flow of audio? In other words, do I get a buffer from the equalizer? The application then has to pass that to the operating tone, has to pass that to the mixer. Or are these file descriptors used only for configuration? In other words, are they configuration or configuration plus data flow?
Yeah, I can guess what your point, and maybe about the for example the some media driver also supported like the bypass mode. If the equalizer and the audio output connected directly in hardware side, and there is no way to getting the result after the just equalizer. So the bypass mode is needed, and some capability maybe can get from the device, and but the equalizer itself it should be done on the equalizer device file. That is because equalizer functionality is just equalizing. So some parameters for the equalizer can be injected from the device file. It is the kind of the answer of your question. Sorry.
Yeah, my earphones kind of kicked in a little bit there at the same time. So yeah, I believe it does. So is it? So I guess the question would be your idea there is even if we have the hardware supporting the data flow through multiple things, your idea is to still have different device drivers for each function
different
within the same piece of hardware versus like I know right now the way the audio interface is defined, there's a an I/O control structure, and there's a structure that you pass down that supports different features, and those features are bit fields and different fields within a common driver. And I think what you're suggesting is maybe that you could split that driver into independent ones and reduce some of the traffic between the application and those drivers. I mean, you would still need to be able to send control down to each one of these. But I think your idea here is that you're minimizing that amount of traffic, or at least the complexity of the traffic. Is that your idea?
Yeah. So we actually, I can understand, fully understand what Amy told. Yeah. So,
yeah, I think it's an audio, maybe the background noise again.
Just tango.
Maybe mute again so we don't have the background noise, and I can try saying it again.
Yeah. Quickly, Thiago has a question here, so some comment. I will ask you also to turn off the microphone to let Thiago ask or comment. Okay? Could you please turn?
Yeah.
Thank you. Thiago?
Hi, everyone. Are you listening? Okay. The current implementation works in a days chained way. So the application calls the audio driver, that calls the decoder, that calls the lower half audio codec and I2S, for example. According to this new suggestion, there would be different device drivers that could call the hardware itself, because some audio codecs already has built-in equalizer, volume control, gain control, balance and bass and treble controls, but some of them doesn't have it. So we can handle that in software. If I understood the suggestion is that these multiple device drivers could handle this better. handle better these hardware capabilities. And if it's empty, it's not available, we can handle that with a software device driver or something like that. Is that true, Kayoshi?
Mm-hmm. Yeah. So okay, if the hardware supporting the some decoders and the several so rule is maybe the monostic in that, and this upper primary just define the separate interfaces. Okay. So the how to say driver and if there are some separated functions, not only specific for the audio function, like kind of just the DSP example. It can be used as a equalizer or the mixer or something else. And so in that case, it's not how to say the monosync audio devices and device block, hardware block. So it can be separate. So that case so can be cured on yeah. So sorry, I'm not sure that this is answer of your question, but this is maybe guessing also.
Maybe Masayuki can help us. Maybe he works with you and he understands a little bit how it works, and maybe he can help us. Masayuki, do you can help us in this discussion, or you suggest we discuss it later in the mailing list? What do you suggest in this case? First of all, do you understand the KMPT questions to Kodayumi-san, and can you help us to get a better understanding of these questions, of what is proposing here for this modification?
Hi, Alan. I suggest Koizumi-san should send a new issues or new proposal to GitHub, so for updating audio implementation. And I think, in my understanding, there is many configurations for audio, so which, for example, so some audio device has hardware equalizer or hardware decoder, and in some cases there is no such hardware accelerated. So there is so many configurations, and also there is some how to say we need to consider power consumption as well, and maybe need to understand some kind of limitations. So anyway, we need to push send this kind of proposal to GitHub or mailing list first, and then discuss in the community later. So including Ken and other who want to discuss with this kind of audio discussion. Yeah.
I personally think that the mailing list will be a better place than GitHub.
Mm-hmm. Okay.
Yeah, I agree with Ali. Okay, Thiago also want to do some comments. Okay, Thiago.
Let me know if you can talk more about this subject. But I have made some questions from YouTube, and I think Petro also did some questions. We could see those questions in there. If you want, I can say there, here, or
yeah.
I don't know.
Maju, please put the Thiago question again in the YouTube, and then.
Okay, 1 minute.
Okay, thank you.
Thank you.
Right. So the audio structure allocates the audio buffer and take care of it. How would you handle hardware-specific limitation like block alignment, for instance? Did you understand the question?
Let me complete the question. I would say that the proposed approach of Takayoshi, that is implemented different device drivers, would be better handle these questions, because with different height drivers, we could handle differently the auto buffer and cares for block alignments and something like that better in a different approach. Don't know, my guess.
Yeah, I don't see anything in the audio driver that would preclude having different drivers for each of these. You know, even if it's an audio chain that does this in hardware, I don't see any necessarily drawback or limitation of doing this. I think one of the main things to consider is if you are trying to do things where you're implementing an equalizer in your application and the hardware doesn't support it, and you want to get access to that data stream, I think the solution we come up with should have the ability to understand, is this a hardware chain that's where the data's flowing, or do we need to have the ability to have those audio buffers passed back to the application to do some software task and then down to the next driver, right? So I think that's the main thing I was getting at. Is I like this mode. I mean, it's not a massive number of drivers that you have to write, and I think the existing architecture will support this with some extensions, of course. But the main thing is to understand not just the control path, but also the data flow path, and when do buffers automatically go from hardware to the next block, or when do they need to pass back through the file descriptor or back to the application level for additional software processing. That's the main thing I was getting at, which that's something we could certainly discuss through the mailing list.
So one question. I got some words from you right now. So the audio driver uses this question like the first idea. I mean, the thing is the and basically usually the audio signal is fixed in the hardware, so the audio is the functionality control is whatever is good enough.
I didn't catch the last part of that. Usually the audio, so the audio normally is done in the hardware. And I didn't catch the last part of that.
Koizumi, please write in YouTube chat because your connection is a little bit with issues. We cannot listen you correctly.
Okay.
It is cutting.
Of course. Thank you. Yeah. Sorry for using many times. Okay. Thank you very much.
Just write it in the YouTube chat, and we will ask it to Ken. Do you have the YouTube link? Just enter in the YouTube channel or in NuttX.event. We have the link to this YouTube transmission, and you can put the message in the chat because, or if you want to try to speak again, I don't know what you think, Ali. What should be best?
I think that it is quite hard to continue the conversation because there is a lot of noise, and the answers and the questions are, at least I feel them like they are a little bit of things. So there is some misunderstanding. If we move all this on a mailing list and it will be in a written form, it will be easier. Also, Koizumi-san mentioned that he had a surgery to recover his hearing, so he cannot hear. That is, or he cannot hear perfectly. So it's better if we all move to the written part, written conversation. I would propose that we actually hijack now the whole plan, and we invite Tiago to present his part, which is also audio related, and then we move further with the schedule.
Right.
We cannot hear you.
We cannot hear you. You are saying something, but we cannot hear you. Even when the microphone was unmuted, we could not hear you.
Now you're also muted.
Yeah, Ken, you are muted. Yeah, try again.
Do that again?
Now we can hear you.
Listen.
Okay. I was playing with my earphones and it switched over again. I said there was also a question from Petro how to integrate the automatic echo cancellation into the audio pipeline. I guess that would depend on how it's implemented, whether that's a hardware function or that's a software function, right? And I think this kind of gets back to that same discussion. If it's a hardware function, then that's a specific driver and a specific function that we would have to add into the audio capabilities. The structures there have bit fields to define the different capabilities for your particular audio hardware, your particular driver, right? So it would be an extension to that if it's a hardware function, or even if it's a software function, right? And so then it would have to be an extension, based on that. If it's being done in software, which I wouldn't think you could do echo cancellation in software, it would just be an extension to the driver for that. And so it would be very specific to the hardware implementation for that echo cancellation. But I think, as part of the discussion on the list, that's something we could certainly discuss of how to add that and what, in terms of the control and the data flow, right? How do you integrate that into that audio subsystem?
What do you think if we look at how things are implemented in ALSA and we create our own subset? Because we cannot have support for the full ALSA. At least I looked at that. But I'm fairly sure that we can inherit some things from there which have been proven as working.
Yeah, I think that's a good idea. In fact, last night after you asked me to join this, I kind of looked at the ALSA driver, the architecture a little bit. I know when I did the NuttX audio, I couldn't just pull in ALSA, right? And so what I ended up doing was looking at the USB audio drivers and the headers, and I kind of mimic things after USB audio. And that's kind of where the NuttX audio stuff came from, a lot of the headers and a lot of the stuff that I added there. Now, when I added all that, I defined all kinds of structures, and mainly I was using an MP3 decoder at the time when I decided to add it. Right, I didn't have the equalization. So most of the stuff that has feature support there, I didn't. I just added it because I realized this is stuff that we might need at some point. Some of that has been filled in. So yeah, I agree with you that looking at different architectures and that you can't just copy those in, of course, that's Linux code. But we could borrow ideas from that to say, how do they do it? Is there a better way for us to do this in the NuttX audio? Yeah, absolutely.
That's something that I'm interested too, because I've made a question on YouTube chat about some auto server service for the NuttX, like something like Pulse Auto or Jake or something like that. And that's related also. So that's something that I would like to see on NuttX soon.
I personally think that we should have something that scales, and ALSA has been proven to scale fairly nice, because at least my personal opinion is that we will see more and more microcontrollers with audio capabilities in the next years. And we should be able to have this as a proposition. If you want the bleeding edge SoCs, microcontrollers, then take NuttX. It works out of the box. It has many features, and you can develop your product as a business proposition. Because in this moment, the implementations that we have are kind of splitted. Presence uses its own audio. Me and my colleagues did some work to get some features working with Presence directly on NuttX, but it cannot match the in-house solution, let's say. And that will probably happen with many other boards, and it's a pity. We should have something that works the same, checks for capabilities, and then it just works.
Sorry, I will jump in. Sometimes, like, the hardware capabilities may be not enough, and we need a way to switch some hardware capability, for example, the equalizer off, and re-implement it with the software if we think that it will give us a better quality. And the same for the other parts of the audio pipeline. So in general, it's like what I see from this presentation, it's like a set of devices, set of drivers that like pass the data output from one block to the input for another block, and each of those blocks can be replaced as I expect, but maybe it is not.
I would expect those blocks to be software or hardware modules that can be detected at runtime or plugged in. So something that works
driver output, and the application need to redirect that to the input of another block. That is like increasing number of system calls, especially in some kernel mode. So that differs a lot from performance perspective.
Sure, that will add a lot of latency and increase the power consumption. So that's why I think that we should look at how ALSA did the things, and then try to define something that we all agree with and start working towards that goal.
Yes, I like that idea.
Okay, then I propose that we move to the mailing list so that everybody can share its idea. Maybe somebody has a better idea.
Yeah. Just a comment. We still have just one question there for our here, Gideon. Guiding
sorry, I didn't see the question since I cannot see YouTube.
Yeah, Maju, could you please put it in the screen in the YouTube? He's asking, how about? Thank you. How about format negotiation? Can be dynamic? format negotiation?
The current audio system does have the ability to query the driver on the formats that it supports. Yeah, so when I first created it, I did add that capability. So already the application can query as it opens the audio device. It can query, hey, what are your capabilities? And one of those queries is the format support. So yeah, it could be dynamic. Now, it might be that during our discussion on the mailing list, we decide to extend or change that, enhance it. But yes, it certainly can be dynamic.
Okay, perfect. Thank you, Ken.
Also, Ken, we did the port for the bitrate converter. So now the NuttX audio is able to do bitrate conversion. At least it's tested on Spresso. So that is also something that we should probably think about when we implement the framework. Because if you query the capabilities and you're not matching in hardware what the software requires, you can automatically include the bitrate.
Yeah, that's a good feature.
The same for the format itself. We can try to software decode the format.
I think that is a little too CPU intensive, at least for some formats.
Yes, it can be.
Guys, it was really nice to see so many discussions and so many great ideas. As we mentioned, let's continue on the mailing list. And now I think that it is time for Tiago to hijack our presentation list and show us something audio related.
Okay, let me share my screen. Sorry. You can talk, Takayoshi.
Hello, yeah? You mean the my screen?
No. Tiago will have the next presentation.
Next one. Okay. Yeah. Thank you, everyone. Thank you for your comment and questions. And just one thing. Let me say one thing. Just so now let's please let's keep continue the discussion. And this the purpose of this proposal is to see if we can generalize the functionality of the audio, which is tremendous variety. We know, the audio is very unique for each devices. So it is easy to implement its specific driver, but it's not the general. And NuttX is kind of the general thing. So this is a trial. So let's try. Let's keep discussion. Thank you very much.
Thank you, Koizumi-san, for being today with us.